Okay, guys, so I just want to show you how to use Desmos to your greatest ability when we are graphing these radicals, how to get the tables, how you can use it to plot the points, and where you can find some of your math features that will be very helpful. So the way you get your graph when Desmos opens up is it counts by 2 as your main lines and grid lines. I personally would say I like mine to match the graph that I'm putting the function on, or like if it's Delta Math, the graph they have drawn. So if you go here to the right hand section and you click on the wrench, you'll see that they have lots of options to switch this around. So axis numbers I would leave. I like to take minor grids off. 10 by 10 is usually pretty good, and they're just keeping it this weird number to keep it proportionate. I like my steps to go by 1, so then I have a 1 per line, and it's easier to keep things, again, proportionate. If you happen to have a graph where it's counting by 5s or 2s, you can change your steps to 2s, and so that way, again, it will match and look the way you want it to. I'm going to go back to the 1s because that's the one I prefer. And then once you set that up, you can close it. If we come over here, down here in your left-hand corner, you have your keypad. This has your square root bar. It has your inequalities if you need it. It has function notations for things if you need them later, stats, miscellaneous, all kind of good fun things to do. Your histograms, dot plots, box plots, things that you probably learned already how to do on your TI-84s. But to use Desmos, because again, it is embedded in your EOCs when you have those EOCs, and you're allowed to use it in our class whenever you want. So we're doing radical functions or square root functions. So if we just put in our parent function, it graphs it beautifully. If you would like to see what this coordinate is without having to actually like scan down the line and find good intersection points, if you come over here to the gear that's right above your function and hit table, it'll give you a table. It will always give you -2 to 2. And in this case, that's not really helpful because that's only one good point. If you come to the bottom of your table, if you go to the open space, you can put whatever number you want. And so 4 and 9 are obviously good roots. But if you don't know what numbers you want, you can hit enter and it'll fill in the entire puzzle, and you can go indefinitely. But for this, and then as those numbers pop up in the table, it will actually plot those points. Notice that in the negative, it is undefined because when you take the square root of a number, it's an imaginary number. So it doesn't, this is a real coordinate plane of real numbers. So those don't exist for square root functions on a coordinate plane graphed this way. You can also go in and delete these if you don't want those points showing on your graph, which is why maybe it's better for you or easier for you to put in the numbers that you know are good square root numbers. But if your function is moved around a lot to the left or the right or up or down, or the dilation's changed as far as its increasing and decreasing rate of change, you might just want to look at all of them for a little while to get really comfortable with it. But it does then plot those points, which you can click and know what's where. But hopefully this will help you some with your graphing and make it a little easier to transfer it to paper correctly and really neatly. If you have questions, just holler, guys. Thank you.